So let's talk about how we can actually estimate the cumulative hazard for this group once we've gotten to the group. So we can represent each of these data points in the form of a survival table, which we have seen before, where we have a set of patients. Here we have 6 patients, and for each of them we write the outcome, which is the event times or the censoring times. Here we can see that we have one censored observation, which we write as 27 plus, and we have 5 non-censored observations for which we write the event times. And now once we have a table of this form, we have seen how we can use survival estimation with the Kaplan-Meier method to come up with a survival function that uses this data. But the Kaplan-Meier estimator is not the only estimator we can use. One other estimator, called the Nelson-Allen estimator, allows us to estimate the cumulative hazard of the population instead. And we won't go into the derivation of this. We'll go through an example of generating a cumulative hazard estimate for a population. So here we have, once again, the formula for the cumulative hazard, and we have the table where we have the data that we will use to estimate the cumulative hazard. So let's look at this expression in a little more detail. We have the sum from I equals 0 to t of di over ni. And the definitions of di and ni are the same as before. And as a reminder, di is the num that died at time I, and we have ni, which is the num that survived to time I. And so those are the quantities that we have seen previously when we looked at the hazard. And remember, the cumulative hazard is the sum of the hazards over time. So let's say we wanted to look at the cumulative hazard for some time. Let's pick that time to be 33, just for the purposes of this example. And let's try to estimate the cumulative hazard at 33 using this Nelson-Allen estimator. And so we have the sum from I equals 0 to 33 of di over ni. Now, this is looking at the number of patients who have died at every point in time. Now, when we look at our data, let's look at where the deaths occur. And let's specifically look at where the deaths occur between 0 and 33. So the first patient has a death occurring after 33, so we won't look at that. Patient 2 has a death before 33, so we'll have to look at that. Now, patient 3 is censored before 33, but that is not a death or event. Patient 4 has an event before 33. Patient 5 does not have an event before 33. And patient 6 has an event before 33. So there are 3 time points that we're going to care about, which are going to have a numerator that is non-zero. And so let's look at this sum. So now we have the sum from 0 to 33 of di over ni, but we know that di is only non-zero for these 3 event times. So we can represent the sum as first d5 over n5, because our first event is at 5. Our next event is going to be at 30, so it's d30 over n30. And our next event after that is at 32, so d32 over n32. And let's compute each of these quantities. So d5, remember, is the number that died at time 5, which is going to be 1. And n5 is the number that survived to time 5. And we can see all 6 patients survived to time 5. Then we have d of 30. So we look at how many patients survived to 30. So we have patient 1 who survived to 30, patient 2 survived to 30, patient 3 who we don't know whether they survived to 30, so they won't be in our denominator, and of course patient 4 survived to 30. Even though they died at 30, we still include them because survival 2 is defined as up to that point in time. And finally, patient 5 survives to 30. So we have 4 in total that survive to 30 and 1 who has an event. Finally, we have D32, which is going to be 1 again, and N32, which is the number of patients that have survived to 32. And here we have patient 1, patient 2, and patient 5. So we have 3 in our denominator. And so we have these three quantities, which we can sum to get a total sum of 0.75. So 0.75 is our estimate of the cumulative hazard at time equals 33. Of course, our time could be any quantity between 0 and infinity, and we can get our cumulative hazard estimate for any of that.